Hi, this is Victor and welcome back to my math tutoring channel. In this video, we'll talk about sequence and series. Let's start. A series is convergent if its limit, when its variable goes toward infinity, if its limit goes toward a constant number. We say it converges to that constant number. Example, if I take the limit of 1 of n when n goes to infinity, this is an easy example. So 1 divided by infinity is 0. So we say that series converged to 0. If I take another example, if I want to study the limit of n divided by n plus 1 when n goes to infinity, and here I would say infinity divided by infinity plus 1, it's infinity. Infinity divided by infinity is undetermined. Let's see if I can make it something determined. So it's equal to the limit when n goes to infinity. And here I keep n in the numerator and I factor out n in the denominator. So it becomes 1 plus 1 over n. And if I multiply n by 1, it's n, and n by 1 over n, it's 1. So I come back to my original value. So now I can simplify in n and n from the numerator and denominator. I would have the limit when n goes to infinity of 1 divided by 1 plus 1 over n. And when n goes to infinity, 1 divided by n goes to 0. So my series will be equal 1 divided by 1, which is equal to 1. So I say that series converges toward 1. Converge to 1. Okay. When the limit of a series, when n goes to infinity and then I have the numerator goes to infinity and the denominator goes to infinity, this is undetermined, then I can apply the hospital rule. The hospital rule is I find the derivative of the numerator and the derivative of the denominator. Let's take an example. If I take I want to study the limit when n goes to infinity, or when x in that case goes to infinity, because I want to use x. It's easier for you to understand when I do the derivative. For the beginners, I'm talking x squared plus 2x plus 5 divided by e to the power of x. And when x goes to infinity, so infinity squared is infinity plus 2 times infinity, infinity, and infinity plus 5 is infinity. So this is equal to infinity divided by e to the power of infinity is infinity. So this is undetermined. So here let's apply the hospital rule. So I find the derivative of the numerator and the derivative of the denominator. So I do the limit when x goes to infinity, and the derivative of the numerator, derivative of x squared is 2x, and the derivative of 2x is 2 divided by the derivative of e to the power of x is always e to the power of x. And then I see 2 times infinity is infinity plus 2 is infinity divided by e to the power of infinity is infinity. So I will apply the hospital rule again. A hospital rule. So I would do the limit when x goes to infinity, the derivative of the numerator divided by the derivative of the denominator. Derivative of 2x is 2, derivative of 2 is 0, and the derivative of 2 to the power of x is of e to the power of x is e to the power of x, and this becomes 2 divided by infinity, which is equal to 0. And we say that that series converges toward 0. So we say a series is convergent when it converges toward a constant number, and it is divergent when the limit when x goes to infinity is equal to infinity. We say that it is divergent. But if I have a constant number 0, 1, 2, 3, 4, 5, I say it converges toward that number. Let's take another example. And I will show you how to use the hospital rule. Even if you don't have a denominator, we create a denominator. So let's take the example. Let's say f of x is equal to 1 plus 1 divided by x to the power of x. Yeah? And I want to study the limit when x goes to infinity to f of x, which is equal to the limit when x goes to infinity to 1 plus 1 divided by x to the power of x. Yeah? So here, 1 divided by infinity, when x goes to infinity, this become 1 divided by infinity is 0, and 1 to the power infinity, I would have it's equal 1 to the power infinity, it's equal to, it is undetermined. 1 to the power of infinity is undetermined. So now I know my equality is jealous. Whatever I do on the left hand side of the equality, if I do it on the right hand side of the equality, I maintain the integrity of my equality. So if I do ln of f of x equal ln of 1 plus 1 over x to the power of x. Yeah? And I want to find the limit when x goes to infinity. So I do the limit when x goes to infinity of ln of f of x, which is equal to limit when x goes to infinity of ln of 1 plus 1 divided by x to the power of x. I know ln of x is equal 1 over x. That's a formula that we can use it. So now I can, and I know the logarithmic rule of ln, let's say x to the power of 5 is equal 5 ln of x. So I will be using those two formulas to solve my problem. I will start with this. So I take that part of my formula. So the limit when x goes to infinity of ln of f of x is equal the limit when n goes to infinity, and I can bring the x here according to that rule, logarithmic rule, is equal to x ln of 1 plus 1 over x. Now I want to use that rule that is here. I know the ln of x is 1 over x. So this is equal limit when n goes to infinity of x, and instead of putting ln of 1 plus 1 of x, I will put 1 divided by 1 plus 1 of x. Okay? Now I can write this x differently. So this is equal limit when n goes to infinity. I will write this 1 divided by 1 plus 1 of divided by x divided by 1 divided by x. So because I know like 2 divided by 3, 5 is equal 2 over 3 times 5 over 3. So I flip it when it is division, I flip it and it becomes multiplication. So if I flip this and I make it multiplication, if I flip this and make it multiplication, I would go back to my original formula. So I'm fine with my logic. So now when n goes, not n, sorry, it's always x. So when x goes to infinity here, 1 over x is equal to 0, and I have ln here. ln. Actually, it's like that. X ln of, I have x ln. Okay? So when x goes to infinity, this becomes 0, and I have ln of 1 divided by 1, and here when n goes to infinity, this becomes 0, and I know ln of 1 is equal to 0, so it's equal 0 divided by 0, and it is undetermined. I can use my hospital rule now. So just to make sure you understood, here I forgot to put the ln, and then when I bring the x here, I copied it without the ln, but I have to keep the ln. And this x here, I put it here, and when ln goes to infinity, 1 over x goes to is equal to 0, and this 1 over x is equal to 0. So this become ln of 1 divided by 1. ln of 1 is equal to 0, and divided by 0 is undetermined. So I can apply my hospital rule. And now I have to do the derivative of the numerator times the derivative of the denominator. The derivative of ln of, now this is the derivative, that's a derivative here. I can use that part of the formula. Sorry. Before I used only this part, and now I will use that part of the formula. So derivative of ln of u is equal 1 over u, and in my case, my u is equal 1 divided by 1 plus 1 of x. So it become 1. So it become 1 divided by 1 plus 1 over x, multiplied by the derivative of 1 over x, and the derivative of 1 over x is equal x to the power minus 1, and this is equal minus 1 x to the power of minus 2, so it is equal minus 1 over x to the power of 2. So the derivative of 1 over x is this. So, and I have to multiply it by the derivative of 1 over x, which is minus 1 over x squared. So it is 1 times minus 1 over x squared. And in my denominator, the derivative of 1 over x is minus 1 over x squared divided by 1. So now I can simplify this with this. So my final answer would become the limit when n goes to infinity of 1 divided by 1 plus 1 over x. Okay. So when n goes to infinity here, 1 over x goes to 0, and I have my limit, this is equal to 0, and my limit would be equal to 1. So I can say that ln of f of x is equal to 1, yeah, or log up to the base of e of f of x is equal to 1, and there is one of the logarithmic rule that say log to the base, let's say, of 5 of x is equal to 2. So I can say that 5 to the power of 2 is equal to x, and x is equal to 25. And exactly the same thing here. E to the power of 1 is equal to f of x. So my limit here, when x goes to infinity, goes to e to the power of 1. So the limit when x goes to infinity of f of x is equal e to the power of 1. And we say that this series converges toward e to the power of 1, which is e. So it converges to e. Now let's talk about different type of series. A series is monotonic if it is always increasing or always decreasing, like this is monotonic or this is monotonic. It's always increasing or decreasing, but that series, if I want to draw it like that, it's not monotonic because it's decreasing here and increasing there. Let's take an example. An example of a monotonic series. If I say 1 divided by, I don't know, 1000 to the power of n plus 3. Yeah? This is strictly decreasing. And its limit, it approach the 3. Because for n equal to 1, the first number will become 0.000 plus 1 plus 3. It become plus 3. It become 3.0001. And the second one, when n equal to 2, so 1000 become, when n equal to 2, it become 123 plus 3. So it's equal 3.00060 and then 3. So and n equal to 3, you got it. So this is always decreasing. So because this number is smaller than that number, and the number after it, it's gonna be smaller, so it's always decreasing. So we say it is strictly decreasing, and its limit is approaching always 3, because whatever I replace n with, it's always 3 point, a lot of zeros and then 3. Now we can have two kind of limit. We can have an inferior limit and a superior limit. In that case, for that series, the inferior limit, because it is decreasing, the inferior limit is the last one in my series. So the inferior limit is 3, and the superior limit is the first item in my series, and it is always almost 3. If it is ascending, the inferior limit is the first item and the superior limit is the last item in my series. But if it is descending, it's the reverse. In that case, the inferior limit is equal to the superior limit, so we say the limit is of that series is equal to 3. Let us take another example. If I have a sequence minus 1 to the power of n divided by 2 to the power of n plus 1. This series, because I have the minus 1 to the power of n, if n is odd, it become negative. If n is even, it become positive. So this series goes like that. Sometimes it goes ascending, sometimes it goes descending. So it's neither strictly descending nor it's strictly ascending. So this series is not monotonic. So if it is strictly descending or strictly ascending, we say it's monotonic series. But if it is not strictly ascending or not strictly descending, we say it's not. It is not monotonic. But if I want to study this series, if I want to say limit of that series when n goes to infinity to minus 1 to the power of n to n plus 1. Okay, so when n goes to infinity, let's say n is an even number, it become minus 1 divided, let's say n equal to 1, yeah, divided by 3. And if n is equal to 2, it become plus 1 divided by 5. And if n is equal to 3, it's minus 1 divided by 9. So I see it's alternating, yeah. But if I add minus 1 over 3 plus 1 over 5 minus 1 over 9, it's always plus or minus, plus or minus. I would say, so I will find this series, and when n goes to infinity, so this series converges towards 0. So even if it is non-monotonic, it can be conversion. It can converge. And sometimes it can diverge. I will take another example and I will end my video with this example, and the next video will talk about other kind of series. Let's say the example, let's take the sequence 1 plus cos n divided by n squared. I know that sequence, the limit of that sequence is gonna be between the one that is here, 1 plus cos n divided by n squared, and it is always there is a 1. And then now I will study this one here. So there is a plus, I put plus here and plus here. In my trigonometric circle, I know the trigonometric, it's 0 or 2 pi, and pi over 2. And then this is pi, and this is 3 pi over 2, and then this is pi over 6, I guess, pi over 4, pi over 3, etc. But I know the constant thing is the radius in my trigonometric circle is always equal to 1. So if it is on that side, the radius is equal plus 1, and if it is on that side, the radius is equal minus 1. And because it is a cosine, so it is the adjacent divided by hypotenuse, and so it is between plus 1 and minus 1, my radius. So my cosine n here, it is equal to, here I will put it minus 1 over n square, and here I will put it plus 1 over n square, plus 1 over n square. So now I can delete the plus that is here, and when n goes to infinity, 1 over n square is gonna go to infinity. So this here, 1 minus 1 over 2, this is 0. So 1 minus 0 is 0, and this is 0, 2. 1 plus 0 is 0. So my limit of 1 plus cosine n, this is the limit when n goes to infinity, divided by n square, is between 1 and 1. So this series converges toward 1. Let's cover everything. Let's take another example. Let's take a sequence 5 to the power of n divided by n factorial. And let's say 5 factorial is 5 times 4 times 3 times 2 times 1. So you always decrease by 1 and then you multiply. Yeah. I know the first 4 number of that series is going to be ascending, because if n is equal to 1, I will have 5 to the power of 1 divided by 1 factorial, it is equal to 5. And if n equal to 2, I will have 5 to the power of 2 divided by 2 factorial, which is 2 times 1, is equal 25 divided by 2 is equal 12.5. So it's increasing. If n equal to 3, I have 5 to the power of 3 divided by 3 factorial, which is 3 times 2 times 1. It is 125 divided by 6. And if you do that on your calculator, you will have 20.8. And it's still increasing. For n equal to 4, I will have 5 to the power of 4 times 4 times 3 times 2 times 1. And 5 to the power of 4 is 625. And this is 3 times 2 is 6. 6 times 4 is 24. And if you do that on the calculator, you will have 26.0416 periodic. And now let's take, if n equal to 5, n equal to 5, I will have 5 to the power of 5 divided by 5 times 4. So here it's still between 20 and 26, it's still going up, times 3 times 2 times 1. And 5 to the power of 5, if you do it on your calculator, it is 3,125. And if you do on the calculator 5 times 4 times 3 times 2, it is 120. And if you divide those two numbers, you will have exactly 26.0416 periodic. So here it's not ascending anymore, it is constant, and after that it's gonna go descending. So the first 4 terms of my series is ascending and the rest is not ascending. So the 5th term is this, and after that it starts going down, 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 down. So as of the fifth term, it is descending, and the first four term is ascending. So I know there is a theorem that say if a sequence is huge, like when n goes to infinity is huge, in that case, and is going to infinity, I can disregard a finite number from the beginning of my sequence or from the end of my sequence. The series become, if I ignore the first four terms of my sequence, my series become strictly descending. And the inferior limit of that series, because it is descending, the inferior limit is the last item in my series. So my inferior limit is the last, and my superior limit is the first. And in that case, my inferior limit, this is 5 to the power of n divided by n factorial, yeah? So it is greater than 0, because when n goes to a huge number, 5 to a huge number is a huge number, but divided by something bigger, because it is infinity. Let's say the huge number is 1 million. So 1 million plus 1 million times 1 million minus 1 times 1 million minus 2 until I go back to 1. But it is greater than 0. So it's become 0. I don't know how many 0, but there is something after the how many 0. So I know it is greater than 0. And my first term is the fifth item, which is 5 to the power of 5 divided by 5 factorial. But I want to introduce n in my first term so I can study its limit. So I can say 5 divided by n, yeah, multiplied by 5 to the power of 4 divided by 4 factorial. So my fifth term, this 5 times 5 to the power of 4 is 5 to the power of 5, and this is n factorial here, and no, it's 5. Sorry, it's not factorial. And 5 divided by 4 factorial, it becomes 5 times 4 times 3 times 2 times 1, which is 5 factorial. Because my fifth term is 5, so it becomes 5 factorial. So I don't want this. I want to study my limit when n goes to infinity of 5 to the power of n times 5 to the power of 4 divided by 4 factorial. And when n goes to infinity, 5 divided by infinity is 0, multiplied by anything is 0. So my series converges towards 0. This is 0 here. I hope that you like my video. If you like my video, please subscribe to my channel. And if you put a like to that video, I would really appreciate it. Thank you for listening.